to show you how to do problem number 8. And the problem reads, ozone reacts with nitric oxide discharged from jet planes to form oxygen gas and nitrogen dioxide. 0.740 grams of ozone reacts with 0.670 grams of nitric oxide. Determine the identity and quantity of each reactant supplied in excess. What kind of reaction is it? So ozone is written as O3, and it reacts with nitric oxide, NO, so that means NO3 plus NO. Discharged from jet planes to form, which would be an arrow, oxygen gas, which is O2, and nitrogen dioxide, which is NO2, because the 2 says that there's 2 oxygens. So to balance this equation, we just look and compare to see if there's the same amount of elements on each side. And there already is, so we don't have to balance the equation any further. So the first step is to determine what kind of equation that was, and we decided that it was a replacement equation. So the next step to our problem is we need to find which number is the limiting reagent, and our numbers were 0.74 grams of ozone, so 0.740 grams of O3, and 0.670 grams of nitrogen oxide, or NO. So starting with the top one, what we do is we need to do a conversion factor of 2 to convert it into moles. And we start doing this by putting moles over grams. And to figure out how many grams, we're going to use the molar mass. And to find the molar mass is really simple. All you do is you take the atomic mass, which for oxygen is 16, and since there's O3, you do 16 plus 16 plus 16, or 16 times 3, and you'll get 48.00 as O3's molar mass. The next step is that you're going to have to use a mole to mole ratio, which is very simple. All you do is refer back to our original equation and look at if O3 is balanced to O2. And as you remember, we didn't have to rebalance it, so it was just 1 to 1. And if you cancel out your units, so grams cancel out, O3 would cancel out, and you'll be left with moles of oxygen gas. So if you wanted to write a 0.2 by the mole up there, because we are trying to find oxygen gas for these two problems. So if you put that in your calculator, you would get 0.015 mole of oxygen gas. We rounded it to 3 sig figs because there are 3 sig figs that we started with, so we should end with the same. And now we just redo the process for the second. So once again, we put mole over grams. And to be able to visualize canceling out grams, you can put grams nitrogen oxide. And once again, we find the molar mass. So for NO, it would be nitrogen, which atomic number is, or atomic mass is 14.01, plus oxygen, which atomic mass is 16, and that will equal 30 for the molar mass, times the mole to mole ratio, which is once again going to be 1 over 1 because we never had to rebalance our equation. And then we can cancel out our units. And if we multiply it all out, we will get 0.022 moles O2. Once again, paying attention to sig figs. So our point was to find the limiting reagent, which is going to be the smaller number, and 0.015 is smaller than 0.022, so that means that ozone was our limiting. So our next step is going to be finding the theoretical yield. So what we do for that is take our limiting, 0.015 mole oxygen gas, and multiply it back to grams, so it'll be times grams over 1 mole. And we just put in the molar mass. So for O2, what it's going to be is, if you remember us taking 3/16 before, we'll just be adding 16 plus 16, so it will be 32. And if you multiply that, it will give you 0.480 grams of O2, and you can cancel out your units.
0.40.
0.480. And we paid attention to sig figs again, which is really important. And that's our theoretical yield, 0.480 oxygen gas. So the last part of our problem was to find the mass unreacted. And what's going to happen with that is we're going to take 0.670 grams of nitrogen oxide and subtract it from the grams that we will find. And to find the grams, we're going to take 0.022 moles O2, and we're going to multiply it like this again.
Oh, yeah.
So it's just by 1 conversion factor, which will be grams NO over moles O2. So we cancel out 1 mole O2 because we're trying to get back to grams of nitrogen oxide. And to find the grams, we just use the same molar mass as 30. And then we multiply that and we'll get 0.450 grams NO. And then we'll subtract that number from 0.670. And we will get 0.220 grams unreacted nitrogen oxide. So to review, what we did is we balanced our equation of O3 plus NO reacts to make O2 plus NO2. And it was already balanced, so we didn't have to add anything, but we just already know that there are 1s there as coefficients. And then we decided that it was a replacement problem. And then we found our limiting by converting both of these to moles and finding the smallest number. Then using our limiting, we found the theoretical yield by converting it back to grams. And finally, we found our mass unreacted by subtracting our mole that we found here, converting it back to grams, and then subtracting it from the original. And that's how you do problem number 8.